Hello, geometry. This lesson is entitled Slopes of Parallel and Perpendicular Lines. Well, I'm sure you were taught in Algebra 1, the slopes of parallel lines, the big thing is that they are equal. Okay, slopes of parallel lines are equal. Okay, so if you know that the slopes are equal, like the second sentence says, then you know that the line's parallel. And of course, any two vertical lines, since they're both vertical, are going to be parallel. Okay? Now this first one says, are lines L1 and L2 parallel? And then explain. So we can never go with just looks like. You never want to say, well, it looks parallel, therefore it's parallel. We have to be able to prove ourselves. And the way we do that is by finding the slope. Now don't forget what the slope formula is. So the slope formula, M, is equal to y2 minus y1 over x2 minus x1. So we're going to find the slope of L1 first. Okay? L1, you'll notice that it's crossing through these 2 points. Okay? 1, 5 and negative 2, negative 4. So if we apply the slope formula for L1, again, we're doing, sorry about that. We're doing L1. The slope of that, you do one y value, 5, minus the other, which is negative 4, over the x value, 1, minus the other x value of negative 2. Now please don't forget, whenever you have two negatives next to each other, it becomes a plus. So we have 5 plus 4 is 9. 1 plus 2 is 3. So this one has a slope of 3. So now we're going to find the slope of L2. And if they end up being the same, then we know that they're parallel. So we'll do L2 here. The slope of that, you have one y value, 3, minus the other y value, which is negative 4, over the x value, 3, minus the other x value of 1. So that becomes a plus. We get 7 over 2, which these are not the same. So therefore we would say not parallel. Okay, so again, they have to have the same exact slope in order for them to be parallel. They somewhat look parallel, but we have to go through the proof to show for sure if they are or are not. Now how about writing the equation of a line? Oh, sorry. We have this example first. Which line is parallel to 4y minus 12x equals 20? Well, the best thing to do on something like this is go with the equation that you're given, and find the slope of that first. So what I would do, after I rewrite the equation down here, is I would get y by itself so you can find the slope. Because the best thing to do is put it into slope-intercept form so you can see what the slope is. So I'm going to go ahead and add the 12x over, move it to the right side, plus 20, and then we divide by 4. Okay, we want to get y fully by itself. So we're left with y is equal to 3x plus 5. Now if you're just looking for what's parallel, doesn't matter what the y-intercept is, we just want to look at the slope. So in this case, this has a slope of 3, which means that eliminates this as an option, because that says 1/3. This one says negative 1/3, but there goes our 3 right there. So A must be your answer, because it has a slope of 3 as well. Okay? Now let's talk about that equation. Write an equation for the line parallel to y equals negative 4x plus 3 that contains 1, negative 2. Now if you're given an equation of a line and you're trying to find another one that's parallel, all you need is that slope right there. So in this case, we know we're using a slope of negative 4. So now we have point and slope. So we can put it into point-slope form. Y minus y1 is equal to our slope times x minus x1. Okay? Now if we wanted to get y by itself, first of all, again, the negatives become a plus, so it becomes plus 2. I'm going to go ahead and distribute this negative 4 so we can get rid of the parentheses. So it gives us negative 4x. Negative 4 times negative 1 is a positive 4. So your final answer is we're going to subtract the 2 over. So we have y is equal to negative 4x plus 2. 4 minus 2. So this line right here would be parallel to the equation we're given. And a good indicator if you did it right is, again, these need to match up in order for them to be parallel. We just have different y-intercepts. Okay? So that's how we deal with parallel lines. Now let's get to perpendicular. The slopes of perpendicular. It says if two non-vertical lines are perpendicular, then the product of their slope is negative 1. So what does that mean? The way I like to refer to it is the negative reciprocal. So if you have one slope of 3/4, perpendicular to that is what you do is you switch the symbol and flip the fraction. Perpendicular would be negative 4/3. Okay? These are perpendicular to each other. Or if I were to give you a slope of, let's say, negative 1/2, perpendicular to that would be a positive 2/1, which is just 2. So again, you switch the symbol, flip the fraction. Okay. So here, are these perpendicular? Now they kind of look like it. Do they make a right angle right here? We don't know for sure. We have to go through and show our work to prove if they are or are not. So let's find L1, the slope of L1. Now it gives us these 2 points right here. So we apply our slope formula. y2, we'll call that 2, minus y1, which is negative 2, over x2 over x1, which is negative 3. So that becomes 2 plus 2, which is 4, over 0 plus 3, which is 3. So that's the slope of L1. Now let's go ahead and find the slope of L2. So again, it uses these 2 points right here. So I'll go with this point right here for my y2. So y2, 3. That sounded weird. Our y2 is 3 minus our y1, which is negative 3, over x2, which is negative 2, minus x1, which is 6. So here we have 3 plus 3 is 6, over negative 2 minus 6 is negative 8. And if you can reduce, always reduce. So you can divide both of these by 2, and that leaves you with 3 over negative 4, and that's the slope of L2. So the question is, are they perpendicular? If you look at this slope, we have 4/3. If you look at this one, we have negative 3/4. Those are the negative reciprocals of each other. So yes, they are perpendicular. Okay? Again, their slopes are perpendicular. And if you want to test it, again, you just multiply them together. You should get negative 1. 4's cancel out. 3's cancel out. That reduces to negative 1. So, yes, these two lines are perpendicular to each other. Okay. Last problem. Write an equation for the line through negative 3, 7 and is perpendicular to y equals negative 3x minus 5. Again, we look at our slope, but we want perpendicular. That means the slope that we want to use has to be perpendicular to negative 3, which we switch the symbol, so positive, and flip the fraction. And again, there's an invisible 1 underneath that 3, so when you flip it, it becomes positive 1/3. Okay, so that's the slope we're going to use. This is the point we're going to use. We're going to put it in the point slope. So we have y minus our y value is equal to our slope times x minus our x value, which technically we'll put brackets there. When you have two negatives, again, that becomes a plus. So let's go ahead and rewrite that. So we have 1/3 That becomes x plus 3. But again, we're going to go ahead and get y by itself. So we're going to distribute that 1/3. So that's y minus 7 is equal to 1/3 times x is just 1/3 x. 1/3 times 3, well, you multiply across, so we're going to end up getting 3 over 3, which is just 1. And for our last step, we're going to add the 7 over, and we're going to combine like terms. So our final answer is y is equal to 1/3 x plus 8. And this line here is perpendicular to the line above y equals negative 3x minus 5. And again, make sure your slopes are negative reciprocals of each other. And that's how we know if they're perpendicular. Okay? So this is parallel and perpendicular lines. I hope that made sense. And I wish you well with this video.